Hello everyone. Hope you all are doing fine. In this video, I'm going to explain about one of the application of derivatives, that is increasing and decreasing function. So let me go to the topic. Increasing and decreasing function. This topic is from class 12 CBSE topic. Now, in this video, first let's see what you mean by increasing and decreasing function with an example. And next, we shall see what are the real life examples for increasing and decreasing function. Number three, find the intervals for which the polynomial function are increasing and decreasing. So these are the three things we are going to cover in this video. First, let's see what you mean by increasing and decreasing function. For that, let's see the diagram. With the help of the diagram, I am going to explain about increasing and decreasing function. So consider the x-axis and the y-axis. Consider the function y equal to f of x. This diagram is for the explanation of increasing function. Here, let me draw another diagram for the explanation of decreasing function. X-axis, y-axis. So now let's consider the function y equal to f of x. This is an example for decreasing function. Okay. Now let us take 2 points x1 and x2 along the x-axis. So just you join x1 and x2 with this curve, and this length will be your f of x1 and this length will be your f of x2. Similarly, for decreasing function also, let us consider 2 points x1 and x2, and this will be your f of x1 and this length will be your f of x2. Now let's come to the main meaning or definition of increasing and decreasing function. So now if you consider the interval I will be from here to here. Similarly, the interval I will be from here to here. This is an interval I. Now, let the function f of x be a real valued function defined on the interval I, defined on I. Then, f of x is said to be an increasing function. What's the condition? Similarly, f of x is to be a decreasing function. What's the condition? Let's going to see that. Now, f of x is to be an increasing function if whenever x1 is less than x2 imply f of x1 also less than f of x2 for all x1 comma x2 belongs to the interval I, it's said to be an increasing function. The condition is x1 less than x2 imply f of x1 less than f of x2. Look at the first diagram here. From the diagram, we all know that your x1 will be less than x2. Obviously, x1 is less than x2. Look at the value of f of x1 and f of x2. F of x1 is from here to here. F of x2 will be here to here. So obviously f of x1 is less than f of x2. So this curve is an example for increasing function. Similarly, the function f of x is said to be a decreasing function. F of x is said to be a decreasing function, then what's the condition? So if x1 is less than x2 imply f of x1 will be greater than f of x2 for all x1 comma x2 belongs to the interval I, then the function is said to be a decreasing function. Here it is decreasing, here it is increasing. Look at the second diagram. Obviously, x1 is from the origin to this distance x1 and from origin to this is x2. Obviously, x1 is less than x2. But look at f of x1 and f of x2. We know that f of x1 is here greater than f of x2. This is true for all x1 comma x2 belongs to the interval I. Therefore, the second figure is an example for decreasing function. Hope you all have understood the meaning of increasing and decreasing function. Let me revise the condition once again. F of x is said to be an increasing function if x1 less than x2 imply f of x1 less than f of x2 for all x1 comma x2 belongs to the interval I, whereas f of x is said to be a decreasing function if x1 less than x2 imply f of x1 greater than f of x2 for all x1 comma x2 belongs to the interval I. Now let's see mathematical examples for increasing and decreasing function. So now let us consider the function f of x equal to exponential function for all x belongs to R. So the domain of exponential function will be set of all real number. Now let's sketch the graph of e to the power x and then let us check whether it is an increasing function or it is a decreasing function. This is the x-axis and this is the y-axis and this is the origin. Whatever be the graph, usually let us take certain values of x and find out what are the values of y, plot those values of y on the xy plane and then join, you will be getting the graph of the given curve, that is exponential curve. So this is x and this is f of x will be y. Now if x is 0, your e to the power 0 will be 1. If x equal to 1, e to the power 1 will be e. So the value of e, we all know that lies between 2 and 3. So the approximate value of e will be 2.7182, etc., etc. So now let's plot those points on the graph. So 1, 2, 3, 4, 5 and here it is 1, 2, 3, 4, 5 and here it is -1, -2, -3 and so on. Now here, so this is when x is 0, y will be 1. When x is 1, it is e, lies between 2 and 3, that is 2 point something. When x is 2, it is e to the power 2, 2.7 the whole square. So it may be higher values. The graph goes like this. Say for example, when x equal to -1, e to the power -1, that is 1 upon e, that is 1 upon 2.71. So it will be somewhat closer to the x-axis, but it is the values of x is negative, it will be closer to the x-axis, but not touching the x-axis. So this is the graph of e to the power x, y equal to e to the power x. Always the exponential function will passes through the point 0, 1. Now, when the values of x1 is -3, x2 will be -2. So your f of x1 will be less than f of x2. Similarly, x1 is -1 and x2 will be 1. Your f of x1 is this, f of x2 will be this. Therefore, this is f of x equal to e to the power x is an increasing function on the set, on its domain. That is, f of x equal to e to the power x is an increasing function on set of all real number. So similarly, you have another example for decreasing function. Suppose y equal to e to the power minus x for all x belongs to R. So now let's draw the table, values of x and values of f of x. Here we have taken the curve is e to the power minus x. When x is 0, e to the power 0 will be 1. Whereas when x is minus 1, it will be e to the power 1. When x will be minus 1, it is e. So here it will be the value of y lies between 213, that is 2.71 when x is minus 1. So here you will have, here it is 0 comma 1. Similarly, when x is minus 2, e to the power minus of minus 2 will be this. So that is 2.71 the whole square. So it will lie between somewhere here greater than 4. Similarly, when x is equal to 1, it will be e to the power minus 1, that is 1 by e. So the value will be coming down. So now let us join all those points. So this is 0 comma 1. This is the graph of y equal to e to the power minus x. So now let us consider x1 will be minus 1 and x2 will be 1. So your f of x1 is this is your f of x2. So x1 is equal to minus 1, x2 equal to 1. Obviously, x1 is less than x2. But look at the diagram, your f of x1 will be greater than f of x2. Hence, this is an example for decreasing function. Y equal to e to the power minus x is an example for decreasing function. So far, what all the things we have seen, let me recollect and then I shall proceed with the other concept. We have seen the meaning of increasing and decreasing function, and we have seen the examples for increasing and decreasing function. So the meaning is, when do you say that the function f of x is an increasing function? Whenever x1 is less than x2 imply f of x1 also less than f of x2, then we shall see the function f of x is an increasing function. Whereas x1 is less than x2 imply f of x1 is greater than f of x2, then we shall say the function f of x is a decreasing function. Simple example for both. First one is y is e power x is an increasing function on R. Y equal to e to the power minus x is decreasing function of R. Now let's see some of the real examples of increasing and decreasing functions. So to make sure that you will understand concept more clearly, for that purpose, I'll explain to you one of the real life examples of increasing and decreasing function. Let us consider the salary of a person in a company or in a firm for 5 years or 10-year duration. So let us consider the years will be marked along the x-axis and his or her salaries will be marked along the y-axis. Say for example, the person is joined in the first year. He or she may get the salary may be 50,000. In the second year, definitely for his performance and some increment, some amount of increment will be there. Let's consider that maybe 60K, and in the third year, he may get a 75K and 90K. So let's plot all those things on the graph. First year, the person's salary is 50K. Second year, it is 60K. Third year, it will be 75K. And the fourth year, it will be 90K. So let's join everything here. So this is the graph of the person's salary over the years. So this is an example for, say for example, this one is 2, x2 will be 4. So 2 is less than 4, but the salary is 60K and 90K. Definitely your f of x1 is also less than f of x2. So it's a real life example for increasing function. Similarly, let us consider the depreciation of a car for first 5 years. So the number of years or years, let's consider along the x-axis, and the value of the car, let's consider along the y-axis. So first year, second year, third year and fourth year. Here In the first year, the person is giving 20 lakhs rupees and purchasing a car. So in the second year, definitely the car price will reduce. So say for example, we'll consider that maybe 18.5 lakh in the second year, the car price. The third year, the car price may be say for example 60 lakh. So now the fourth year it may be say for example 12 lakh. So the price of the car is reducing the year as moving on. So now x1 let us consider 2 and x2 let us consider 4. In the second year the car price may be 18.5 lakh and in the fourth year the cross car price may be equal to 20 lakh. So this f of x1 is greater than f of x2 whenever x1 will be less than x2, but your f of x1 is greater than f of x2. It's a proper example for decreasing function, real life example for decreasing function. Now I hope all the students could understand the meaning of increasing and decreasing function after explaining the real life examples. Now, there are certain functions which are neither increasing nor decreasing. So, which are the function is neither decreasing nor increasing? One small and simple examples, if you consider y or f of x equal to sin x for all x belongs to R. So this is the topic of grade 12. So all the students might have learned how to draw the graph of sin x in grade 11. So now the range of sin x will be minus 1 to plus 1, and if the value of x is pi by 2, pi, 3 pi by 2, 2 pi, I'll consider and plus etc. This side, here it is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. Now let's plot all the values in the graph and you join, you will be getting the graph of sin x. When x is 0, sin 0 will be 0. When x is pi by 2, sin pi by 2 will be 1. When x is pi, sin pi will be again 0. Pi by 2, pi plus pi by 2 comes in the third quadrant. It is minus 1. And then it will be plus 0. Then it is minus pi by 2. It is minus 1, 0, plus 1 and 0. Now let's join these points. You will be getting the graph of y equal to sin x. It will be goes up to, let me take this side and this side. Now look at the graph of y equal to sin x. From minus pi by 2 pi by 2, it is an increasing function. From pi by 2 to 3 pi by 2, it is decreasing function. From 3 pi by 2 to 5 pi by 2, it is increasing function. Similarly, this side minus pi by 2 minus 3 pi by 2, it is an decreasing function and so on. So in such cases, what can you say about the function sin x for all x belongs to R, whether it is increasing function or it is decreasing function? Throughout its domain, function f of x equal to sin x is neither increasing nor decreasing throughout its domain. But if you split the domain into several intervals, minus pi by 2 to pi by 2, or it is only 0 to pi by 2, then you can say that the function f of x equal to sin x is an increasing function. But throughout the domain for all x belongs to R, it is neither increasing nor decreasing. But if you consider the interval as f of x equal to sin x for all x belongs to 0 to pi by 2. In this case, the graph of the sin x will be from here to here. Therefore, f of x equal to sin x for all x belongs to 0 to pi by 2 is an increasing function. But if you consider the entire domain, which is neither increasing nor decreasing. Hope you all have understood now the concept of increasing and decreasing function. Now, let's see the last topic. For the polynomial function, how to find the intervals, at what intervals the function f of x is increasing and decreasing. For that, let's see the second definition of increasing and decreasing function. Every time sketch the graph and applying the condition is highly impossible. So we have another definition of an increasing and decreasing function. The function f of x is said to be an increasing function if f dash of x is greater than or equal to 0. A function f of x is said to be a decreasing function if f dash of x is less than or equal to 0. Why it is greater than or equal to 0? Why it is less than or equal to 0? For that also we have explanation. Let me explain before we solve the problem. This is the graph of increasing function. We all know that x1 and x2. Now let's draw the tangent to this curve. So now if we extend the tangent to the curve to the x-axis, and this is theta. So acute angle, therefore the slope of the curve will be positive. That is why for increasing function, the slope of the curve will be f dash of x dy by dx. Tan theta and dy by dx both are one and the same. You all know that. So y equal to f of x. So here for this curve, theta is acute. Therefore, tan theta will be positive. So the slope of the curve will be dy by dx. That is d by dx of f of x. That is f dash of x, which is greater than or equal to 0 for an increasing function. Now, why for a decreasing function it is less than or equal to 0? Let's see. Consider the graph of decreasing function. This is the graph of a decreasing function. Now, if you take one point on the curve, if you draw the tangent to the curve, so it's making an angle theta with the positive direction of x-axis. Here theta is obtuse, so tan theta will be negative. So dy by dx, that is dx of f of x, will be less than 0. So I hope you all have understood with this meaning the second definition of increasing and decreasing function. Now let's see only one problem of polynomial function, how to find the intervals for which the function f of x is an increasing function and decreasing function. So find the intervals for which the function f of x equal to 2x cube minus 15x square plus 36x plus 17. So find the intervals for which the function f of x is an increasing function, decreasing function. This is the question. Most of the final year paper, one question will be of this category is compulsorily for board exam. So now we are going to use the second definition for this and how to solve this problem. Let's see step by step. So now, first find the derivative of f of x. So f of x, let's consider equation 1. Derivative of f of x is f dash of x. So 2 into derivative of x cube will be d by dx of x to the power n. We all know that n into x to the power n minus 1. So hence d by dx of x cube will be 3 into x to the power minus 1. It is x square. So 2 into 3x square minus 15 into d by dx of x square will be, again apply the same formula. You will get it is 2x plus 36 into d by dx of x is 1. Derivative of constant, you all know that it is 0. So f dash of x is minus 30x plus 36. Now, what's the question here? We need to find the intervals. for which the function is an increasing or decreasing function. So what's the definition says? The definition is f dash of x is positive when it is an increasing function, f dash of x is negative if it is a decreasing function. So how do you test that? Let's solve step number 2. This is step 1 is we have to find the derivative. What is step 2? Step 2, let's find the critical point. For that, equate f dash of x is 0 and let's find out the critical point. F dash of x is 0 imply 6x square minus 30x plus 36 is 0. So which is a common factor? 6 is the common factor. Let's take outside. X square minus 5x plus 6 is 0. We all know that 6 is not equal to 0. So the product of two terms 0 is either first is 0 or second is 0. Let's solve the quadratic equation. We all know that when we solve the quadratic equation, what are the values of x you can go for splitting the middle term. So now 6, the factors of 6 is minus 2 and minus 3. When we add minus 5, when you multiply it is plus 6. So let's solve this. X square minus 3x minus 2x plus 6 is 0. That is x into x minus 3 minus 2 into x minus 3 is 0. That is x minus 3 into x minus 2 equal to 0. Therefore, the values of x are 3 and 2. So, therefore, x equal to 3 or x equal to 2 is the critical point. Now, what is step 3? So after finding the critical point, what shall we do and how to find the intervals for which f of x is increasing or decreasing? For that, let's draw the number line. Minus infinity to infinity. Plot the values on the number line in its order. So, first 2 will come, next 3 will come. Now, the critical points 2 and 3, divide the number line into 3 disjoint parts. Now, let us see which part your f dash of x is negative and which part your f dash of x is positive. So, f dash of x will be 6 into x square minus 5x plus 6. Let's take this part, any random value. Find out whether your f dash of x is positive or negative. Let me take the closest value, that is 4. If I put 4 over here, 4 square is 16. 16 plus 6 will be 22 minus 20. So in this part, our f dash of x will be positive. F dash of x is positive. Now, between 2 and 3, let us take any random value. That is, I'll take 2.5, that is 5 by 2. If I substitute in f dash of x, that is f dash of x is equal to 6 into x square minus 5x plus 6. Let me take x is 5 by 2. So 5 by 2 the whole square minus 5 into 5 by 2 plus 6. So this is 6 into 25 by 4 minus 25 by 2 plus 6. 6 into 25 minus 50 plus 24. So this is 6 into minus 1 by 4, which is negative. So between 2 to 3, your f dash of x is less than 0. F dash of x be less than 0 in this interval. What about from 2 to infinity? So easiest value will be 0. Let us substitute in the place of x 0. We'll get f dash of x will be 6 into 0, 0 plus 6. So which is 36. It's again positive. Dash of x will be positive. F dash of x is positive. So after we finish step 3, how to give the conclusion? So the critical points, divide the number line into 3 disjoint sets. Whereas minus infinity to 2, your f dash of x is positive. 2 and 3, f dash of x is negative. 3 to infinity, f dash of x is positive. Now let's go to step 4. In step 4, let us draw the table neatly. Intervals, sign of f dash of x, nature of f of x. So intervals, according to this problem, the critical point is through 2 and 3. So let's have the interval minus infinity to 2, 2 to 3, and 3 to infinity. So here sign of f dash of x is positive. Here it is negative. Here it is positive. So increasing, decreasing, and increasing. Now let's write the conclusion. Therefore, the function f of x is an increasing function in the interval minus infinity to 2 and of 3 to infinity, because these two sets it is increasing function minus infinity to 2 union of 3 to infinity, and f of x is decreasing function in the interval 2 comma 3. So that's all. So similarly, we have plenty of polynomial functions and exponential functions, and what interval the function f of x is increasing, what interval the function f of x is decreasing. So let me give you problems for you. After seeing this video, using the same step, you can solve, and if you have any queries, you can send a feedback to me to explain your doubt. So this is for your practice. The first question, find the intervals for which the function f of x is equal to 4x cube minus 6x square minus 72x plus 30. And second question is f of x is equal to x minus 1 into x minus 2 the whole square. Here I have given, if you want, in order to find f dash of x, either you can apply the product rule and find out, or you can expand and make it a polynomial function and you can solve. It's up to you. And practice these two problems and find at what intervals the function f of x is an increasing function and the function f of x is a decreasing function. Thank you all. Hope you all might have understood this concept. So once again, quick review of the what all the things I have shared in this video. Let me tell you. First, we are seeing what is the meaning of increasing and decreasing function with an example. And second, I have told you, explained to you the real life examples of increasing and decreasing function. Third, I have explained to you the second definition of an increasing and decreasing function. Last, we have seen one polynomial function, at what interval the function f of x is increasing and the function f of x is decreasing. And last, I've given you some of the practice questions as well. Hope you all understood the concept. So let me see in other video. Thank you. Have a great day.